Okay, welcome back to Chapter 2, starting in Section 4, Chemical Formulas. Let's go over how to read a chemical formula. First up, what we have here are molecular formulas. These are pretty straightforward. It's just a list of all the atoms in the compound and how many there are of each atom. So, C3H8, CO2, NaCl, Al2O3. The top one, propane, C3H8. It's a molecule with 3 carbon atoms and 8 hydrogen atoms. Next up, CO2, carbon dioxide. 1 carbon atom, 2 oxygen atoms. Note, we don't include the number 1. No reason to. If there weren't at least one of the atom, it wouldn't be in there. Then we have sodium chloride. 1 sodium for every chlorine atom. And then aluminum oxide, aka sapphire, Al2O3. 2 aluminum atoms, 3 oxygen atoms. Now, remember, when dealing with these formulas, don't change anything. Any change gives you a different compound. Changing the letters means changing elements. So definitely don't change those. Also, don't change the subscripts. If you change the number, you're changing how many atoms are present, and again, that gives you a different compound. So don't change those things. Another way of writing out formulas is with a structural formula. A molecular formula just tells you how many atoms are present. A structural formula shows you the actual connections between the atoms. Now, it takes more space, obviously, but it gives you information that a chemical formula, the molecular formula, doesn't show you. For example, here we have cyanomethane and isocyanomethane. They both have the chemical formula C2H3N. But as you can see on the left, they have different connections between the atoms. On the left, cyanomethane, you have the carbon surrounded by 3 hydrogen atoms, and then the CN. On the right, the same carbon surrounded by hydrogen atoms, but now NC. That looks like a fairly small change, but it makes them different compounds with different chemical properties. So another way of trying to reflect the structure in a molecular formula, instead of writing it C2H3N, you can sort of start to mimic the actual connections between the atoms. You could write it CH3CN and CH3NC. So only the simplest molecules can go directly from molecular to structural. Okay? These are typically binary compounds. They only have 2 elements in them. Bigger compounds usually have to be drawn out because structure can change a lot. Going back to the previous slide, this is a relatively small example of what's known as an isomer. Same formula, different structure. Isomers can get very complicated very fast. The same chemical formula could have a dozen or more isomers. So for bigger molecules, we typically draw them out. And these days, we have software that makes it a lot easier to do that. Obviously, for this slideshow, I don't have access to that, which is unfortunate. But they are out there, and when you need them, you'll have them. Now, when it comes to the actual names of the compounds, that's what's known as nomenclature, and we'll get to that in Chapter 4. And that'll do it for this lecture. See you next time.